Hey everyone, welcome back to Devs and Sheds. Got Paul, Aaron, and myself. We have been busy the last few weeks. We've been traveling for work. We did want to stream, but please, everyone in the audience, hopefully forgive us. We had the worst internet connection in the countries that we're around, doing a work event in, so it became unstreamable. So apologies, everyone missed the last 2 weeks, I think it is. But we'll make up for it over this week and the coming weeks. For those that are just joining for the first time, let us know where you're joining from. All three of us are based in Victoria over in Australia, so that's Melbourne. As you can see in the backgrounds, or at least in my background today, we usually operate out of our sheds. It's pretty cold over our side. So I think Paul's in his house, and then Aaron has had work in the office, so he's not in the shed this week either. But the idea is we're in our sheds where we've got access to all of our tools and IoT things. In fact, Paul and Aaron, just for your knowledge, I do have a Raspberry Pi wireless Pico in my bag for when we catch up on Friday. So maybe we'll have a Devs in the Shed episode on that. Maybe we'll get to build something with that.
That'd be nice. We could do some feedback into one of our AWS services or something. But last week was pretty awesome. It was good to catch up and have a work event and reconnect with all the people that I work with, interact with like virtually. But yeah, we had planned to stream. We were ready. We had the content ready to go, but just no matter what we tried, like the venue internet was just not good enough. Upload. We tried tethering off the phones. It didn't work. So yeah, sorry about that, everybody. But where's everybody from in the audience today? Like, we know it's been a couple of weeks, but we hope we've got some of our regulars returning. It looks like there's a pretty good amount of people that are watching today, so we'd love to hear from everybody. And Matt, so were there any interesting service releases this week that we should go through?
There were a few Graviton things available in different regions. So Graviton services launched in a number of regions. Nothing specific to APJC. Mookie Monkey, I didn't know that Mars had good internet, but welcome back. I know that you're on regularly. I think Aaron did see one on Full X. It was just a quick feature release, but
what was it called? A composite slot. So this is probably an important one. So I know we've talked, Matt and I have talked a little bit over the episodes around building chatbot, and we've actually started building out a chatbot. This is a new release for what's called a composite slot. So instead of just a data slot where we accept data, a composite slot allows you to add some very basic logic. So you can use that logic to then facilitate filling in data, in other slots. So it's a small update, but it's a pretty powerful update because it helps to create more conversational flow as opposed to just question and answer.
Nice. Yeah, so that's a good one. I do suspect that we're going to be a little bit quiet on updates because we are coming to basically Christmas time, right? Which is reInvent. So our Christmas is reInvent at AWS. So I think we're going to have like a slow trickle of some really cool things. We'll still have like a couple of hundred things coming out a week. But I think some of the big ones will probably pop up as nice surprises for us and everyone else. And
between now and reInvent, it's usually just performance enhancements and small like incremental changes. All of the big stuff they'll keep for the big ticket items for reInvent. So stay tuned for reInvent.
Yeah, we'll share the link in the chat. Yeah, there will be virtual watch parties for reInvent. Paul, you're on top.
Yep.
But anyone that does want to go to reInvent or is going to reInvent, hit us up on LinkedIn or Twitter or something like that. We'll be at reInvent as well. So we're pretty excited to be there doing that. Hopefully we'll have a Devs in the Shed episode there, but we have a ton of other kind of sessions arranged at reInvent there, which is going to be nice.
Yeah, it might be difficult to schedule the traditional Devs in the Shed time. I don't think we'll be able to do that. Well, actually, it'll probably be at midnight for us or quite late in the afternoon. So maybe it will be achievable, but there'll probably be some live streaming events at that time. So we're hoping to have a slot there at some point. But yeah, we'd love to catch up with anybody that is heading over there. And interesting, there are. How are we going to give tickets? Well, if you, Shebang, if you're in Melbourne, there is one way that we could potentially give you a ticket. Now, I'll spruik this in just a second, and I'll send the way you may be able to get yourself a free ticket. But for anybody that isn't aware, like reInvent is, and there are people that haven't been to reInvent, or they're new to AWS or are new to the channel. Like, it is our big release party, like our once a year, all things AWS get together in Las Vegas. Half the casinos on the strip are booked out. There's people everywhere. There's 50 to 60,000 people will be there. It's an amazing event. Tons of like people from the service teams are there. Like, awesome trade hall. Like, plenty of like great swag that you can collect. And heaps of people to like catch up with and see all those service releases. And I don't know, it's a really great event. But
what was
Shebang,
just before you go onto it? Yeah, I was going to say, Paul, what was your favorite piece of merch that you got from last reInvent?
Well, so somebody asked, or was it one of you that mentioned, Gravitron. So when you talked about Graviton, like, this is a full side story, right? But you talk about Graviton, and the way that comes in is, of course, we like Graviton because it's ARM, and your CPU runs cooler, your battery lasts longer, it uses less power. But Graviton is one way to like head into sustainability, right? To build sustainable things. I particularly don't like rubbish. I don't use straws because there's plastic, just waste of plastic all of the time. So I tend to like only take a straw if it's a paper straw. I'm okay with that. But one of the vendors, and I actually forgot which one it is, but I still have the straw so I could look it up and see it. They had metal straws. And I thought
nice.
that was a useful piece of swag because I had metal straws. And although I don't really use straws often at home, my kids, two of my sons, they like to have straws. And so they have the metal straws that we have been used, and I've used them for the last few years. And I think that that's great because it links up to one of my values, which is sustainability and keeping our environment healthy.
Nice. And I really hate it when you have like
hoodie?
Yeah, that is a
What's
reInvent
the logo on
logo.
your hoodie, Paul?
My hoodie logo is, I think this is from 20.
That's reInvent 2 years ago.
Yeah,
Yeah.
2020. Yeah.
Yeah. So that's not your favorite swag? Is the reInvent hoodie every year?
I mean, like,
we have a collection of them now.
Like, I absolutely love my hoodie, and it's my favorite, so I wouldn't trade it. But I think that there still was a lot to be said about thinking. I mean, I guess a bit outside the box rather than some piece of something that might be a throwaway item or a gimmick to something that was like useful. So that's why I was
going to say, like, mega rage wise, right? Like, you get like a paper straw, yet the cup still has like non-disposable plastic, like to put the straw into, right? Like at the top.
Yep.
The lid. Yeah. I
Yeah,
like this. I like this idea from Mookie Monkey. Need to connect the metal straw to the AWS Lambda. Maybe we could use your Pico to put a sensor on the metal straw, a temperature sensor. We can tell whether you're sipping hot or cold.
We could do that. I'm just looking for the link for the way to potentially get a free ticket. And the free ticket is, the way you get it is there's a Deep Racer event. And actually, because of the additional public holiday next week within Australia, that has been pushed out a little bit. So you can definitely win some free tickets. Here it is. I've nearly found it. Where is the registration form?
There'll probably be a number of events, right? There's a couple of game days that you can find in different countries being held at the moment. There's tickets going through other countries' Deep Racer events as well. So there'll be a number of ways to get there. The other thing is, if you do work for a company, like generally companies, if you take some of the business case data that we've got on the website as to why to come to reInvent for learning and training and education, generally you can convince like managers to let you go. But I think if you're a student as well, I think there's student passes, but flights and all of that, if you're not in America, can be quite expensive. So it's best to win it as a prize.
Yeah, winning it is the best. But definitely talk to your AWS teams. Sometimes there are some strings that they can pull, some credits and some coupons around. But that is the one competition that I know of, the AU Deep Racer Championship. So if you've been playing with Deep Racer and you've got a model, that could be one way, and you can win all expenses paid. So that includes your flights and accommodation.
Yeah,
I think there's 3 tickets.
Nice. Excellent. So moving on from Marine then, Aaron, I know that you got a little bit excited a couple of weeks ago when we started doing some work on CDK with, I think it was a WordPress hosted high availability site. Yeah. And you wanted to continue that with your own flavor of like learnings from CDK, right? Do you want to take us through a little bit of that? And I know you've got your screen shared in the background.
Sure. So before I check up the screen, I'm gonna geek out today, right? I'm gonna actually step into my CDK code. I want to show you some stuff that I've built, and we can even jump into the pipeline and see how it works. What I got excited about was so WordPress, like it's very heavily used, right? And it's actually quite a complex deployment. So actually having to deploy all of the components. So as go back and rewatch that episode. I'm not going to talk through it all because there's a fair bit to it, right? But it's quite complex. Another very common solution that I come across in customer engagements is, especially in the SIs, they do a lot of bespoke front-end development, and then they're also developing the bespoke back-end for an existing solution, right? So they might have a big data lake or a big workload in an AWS account or a series of accounts, and they want to build out a specific backend to support a specific front-end application. So we call this a backend for front-end, where microservices or components, serverless lambdas can be reading from a data source and writing to a DynamoDB or writing to something that then's used for a mobile application or a web application. So I wanted to build on from the CDK deployment of WordPress and look at a CDK deployment for statically hosted React app. So in my example is React. It could be any static hosted front-end application, talking specifically to a backend. Now, the reason I'm geeking out on this, right, is because we've done a lot with Amplify as well. So like go and look at some of our earlier episodes around working with Amplify. I think we've done like 2 or 3 at least on different ways of working with Amplify. One of the advantages of using Amplify, right? When you get into the CLI, you create your backend resources, it deploys them all for you. It generates the code for your front end. And then when you build your front end application, all of the configuration for the endpoints, the API keys, all of that stuff is baked into the application, right? So one of the solutions that I've worked across with the SIs in deploying out these types of solutions is understanding how we can do the same thing. Like we want to deploy our backend, but we want to take in this case, I've got a GraphQL. I've used the AppSync or the GraphQL model from a popular AppSync workshop that we have, and I've taken the front-end application so that you can see how using existing workshops, that if you've already done AppSync, if you've already got into some of the AWS workshops, how they all tie together, right? So now I'm deploying that AppSync backend. I'm creating my API key, but it's not as easy as one might think to just go and do a front-end deploy. Now, when I say that, it is very easy to just deploy an asset when you're building during the one step. But some of the nuances that you'll find as I get in and start to show you is that when we do a simple CDK pipeline, there's a single synth step, which actually creates that front-end application build as part of that deployment. But then as you go through, if you need to then tie resources that you're deploying back into that front end, it's already built. It's already compiled, build out the package for the front end asset to deploy, right? So if you use your the simple, I'll jump in and I'll show you the code in a sec. The deploy to S3 bucket construct. It's actually going to take the original asset that gets bound or built during the synthesis step and deploy that. So actually, you're not joining anything into the front-end application, like when we're doing in our development environment with Amplify. So before I actually step into the pipelines and show you all the complexity, let me throw up my screen. I want to take you through. Let me blow this up a bit so it's easier to see. I want to take you through the project structure, because even this is there are different ways of doing like project structures. How do I close this guy? There we go. There's different ways of doing project structures, right? So a lot of people working with CDK are used to having the CDK at the root level, and then everything, which is your assets, inside the CDK folder. So this is a familiar structure here. I actually go a lot further and break this down, remove everything from bin and lib, but I've left it as is for now so that you're familiar with how CDK is structured. But you'll notice that CDK at the moment is actually a subfolder of an actual application that I'm building. So the BFF, backend for front-end application, is actually, if you recognize React, is actually a React application. So I've got my JavaScript here for my app. All of my React app is under source. All of my public is my static HTML, and at this case, it's just the favicon and the static HTML. And then that all builds when we do our local build environment through Webpack into our bundle here. So we've got our static JSS, CSS resources, which actually will be our JSS bundle, right? So Webpack by default goes and breaks it up into a bundle. I'm not messing with any of that, but what I want to do is call out the reason I've done this structure is, as I said, there's multiple structures. Sometimes we'll do like a monorepo style where we have the front end and the CDK folders at the same level. That has benefits. And then sometimes we actually have the CDK with the application as a subfolder inside the CDK, also has its benefits. When working with a compiled application like this, I've found the easiest way, sorry, not compiled application, but bundle like this, I found the easiest way of working with it and understanding it with actually from a developer's mindset in the engagement is that everything in this CDK folder is the backend for this application. So I'm building my resource, my backend resources into CDK. We could even call this backend. It doesn't have to be called CDK. And then everything that I'm doing in there is specific to this application because this is obviously a copy or a clone of a solution that I'm working with in another engagement. They actually have multiple CDK applications to manage multiple parts of a much larger, very complex distributed system. So they have a app which is managing the control plane for a SaaS component. They also have another app which is managing a containerized environment for microservices, which also feeds like a couple of lambdas. And so they have different structures and different pipelines for deploying into that series of accounts for that distributed system. This all bundled together makes sense because anything that's in that CDK folder is specifically the backend for this front end, and we want that bundled together. Pros and cons, you guys, I'm sure will have your arguments around why you would do them parallel or nested or however you want to do it. This I found just works well for the engagement based on all of the other apps that we're deploying into different pipelines. Before I move on, is there anything else?
I was going to say like a little bit about that. No, nothing from the structure, but just looking at chat, we did go down a bit of a rabbit hole with PHP. But one of the questions was around: do we embed CDK in an app? Do we embed the app in CDK, or do we have them run alongside? And I think you've given the example where it's within your app. That makes sense if you know that most of the work is going to be local to that app. I think if you're going to work on a project where there's going to be lots of different apps, you might have a shared CDK repository. Like I've seen that built even within Amazon. I've seen a shared CDK repository on one of the teams that I've been working with. And then the other way is effectively like embedding your apps in CDK. And I actually think that's a really good route to go down if you're doing serverless. But I wanted to kind of get your view on it because I saw it in the comments too.
I 100% agree with that one. So what you just said then is where I would create the boundary, right? So the structure that I would use for an application, which is a serverless environment, and even including containers, right? So you might have container images, you'll have lambdas, you'll have AppSync and the GraphQL. So here I'm actually building an AppSync. So there's my resolvers and that's my GraphQL, right? As a folder, I might have a functions folder or a Lambda folder, and inside that I'll have a layers folder, which has a layer that's shared across all of my Lambdas, and then I'll have a folder per Lambda. For a backend system, so when I say backend system, I'm saying everything that's deployed into an AWS account, so not considering mobile apps or front-end application that gets deployed for web access, but just the backend, 100%. That's where I would start with CDK at the root, and then all of my applications, so Lambdas, AppSync, API gateways, all of the serverless components that make up that distributed system are subfolders of the CDK app. So absolutely flip it around. The reason we use this structure for this one is because, as I said, this is specifically a backend for front-end patterns. So all we're talking about here is the resources that are in this CDK app are specific to the front-end application that we're building. There are, for this, obviously this is a clone, so you don't see the other parts of the distributed system. There are serverless components inside the account that we're deploying into already, and they're managed in another application and with another pipeline, or another CDK app in another pipeline. So when they make changes to those lambdas, they're not being deployed through here because they have nothing to do with this application. What they are doing, though, is there is shared database. So there's an underlying shared data source. In this example, I'm actually creating the DynamoDB instance. However, just to make it self-contained, however, in the actual solution that I'm working on, that DynamoDB, I'm not creating that in this application. I'm actually using CDK to find it based on the ARN, and then I'm using it as a data source for my app sync, but it exists already in the account. So now I'm actually using existing resources in the account to get the data that I need, but everything else data up is specific to this application, and only this application uses it. So that's what we call a backend for front-end pattern. So absolutely different structures make different sense. Makes sense.
The other thing that I like is when like teams have shared resources, right? So they kind of give you a package that you can operate on, or they might be deploying like a whole bunch of master resources, and then your app only needs like to be a subsection of everything, right? And then that model, this is what you've kind of got. It's I
see more commonly. This is a backend for front end pattern, but I see more commonly a monolith, a mono repo where we have the CDK app and then a front end app and then a mobile app all in parallel, because the CDK is actually now an API and all of the backend system for supplying multiple apps, a web app, a mobile app, maybe a couple of web apps, an admin portal, a reporting portal. So there's different ways to basically, or different applications all connecting to the same backend. That makes sense. In this way, it's one backend for one application, and that makes sense. And then if we have a mobile app, we might actually tie the actual CDK into that mobile app. Now, we're not deploying the mobile app, we're bundling the mobile app and packaging it and sending it to the actual app store. But in our code repository, we can still have all of the CDK resources that deploy the backend for that mobile application front end, because they're not going to be shared with anything else. That's the argument that was used for creating this application structure. There is
let's have a look at it. But the other question that we did get was just around a GitHub repo. Is this GitHubbed or going to be GitHubbed, or you can just show us what you've got on the stream?
This is in the I will show you here. It is in the process of being put up into GitHub under AWS samples. So you will be able to access this as a sample, and I can drop a comment on
the YouTube link on the dev
later with a link to the GitHub once it's approved. What I'm going to do in the AWS sample, though, is I want to remove some of this application structure. I flatten a lot of what we've got in bin and lib. This becomes very similar structure then to what you would find in your source, right? So now we have the root level app and index, whereas index.js working together, which is our which would be the equivalent of our entry point, the bin cdk.ts, but then all of the resources. So if I was to add components to my React app, I'd follow the structure of, create a components folder and start adding components into that. So that's the same way that we work with the CDK app, is we flatten it and then we create a components folder. In this case, it would be Lambda or API or whatever we're actually releasing. So I'll go ahead and change this structure, but for the purposes of this demonstration, I didn't want to break it down too much because I want you to see this is still just CDK, like the common scaffold and template that you're used to when you do a CDK init. The one change to that, though, is you'll notice that the CDK out here, so that's the output that creates our cloud assembly. So that's the synthesized CloudFormation templates and any of the zipped resources. So if we've got Lambdas, it zips it up. If it's got our app sync VTLs or resolvers, the GraphQL schema, all of that gets zipped up into what we call our cloud assembly, which gets pushed up into S3 S3, which then CloudFormation uses to then deploy into the different services. That's our output folder there. So we do actually have to make a config change to make sure that when that gets output, it actually gets output to the root of our repository here, because the simple reason for this is when we're working with CDK pipelines, which is different to working with CDK and then using code pipeline as a construct and using code build as a construct. CDK pipelines is an L3 construct that we've developed that has additional components to do the synthesize step and the self-mutate step within the pipeline. When working with that, by default, it's looking for that output folder in the root of the actual source that gets pulled down through the code commit step. So that's it. And I'll just show you how simple it is to do that. In our cdk.json configuration, all we have to do is change the output location to one folder up and CDK out. Now, you could rename this to anything, so it'll drop it.
Is that
in that
important,
folder.
Aaron? Because you've got your CDK that has a manifest, and it needs to reference the files that are outside of that directory, inside that build folder. Like why is it important?
So that's important for the pipeline, right? When the synthesize step, so all the code that runs the synthesize step for the self-mutate is looking for the actual cloud assembly output in the root of your actual of your repository, right? That's the only reason. So when you do a normal CDK init, because the CDK folder is the root, it just builds it into the root of the CDK folder, right? So that's where it's looking for it.
Yep, that makes complete sense. Yeah, so you can't. There's no way to like pass in a parameter to override where it is. However, you just tell the build or the Webpack build or the build parameters of CDK to where to put the outputs. Yep, okay, that makes sense. Correct. Now I understand what we went backwards and forwards a lot about in the chat, because you asked about it, but I didn't quite grasp until you see it, right?
Yeah, absolutely. So when we get into pipelines, if you're familiar with CDK pipelines, that's the synthesis. This is the synth step. When it goes through and synthesizes everything out, this asset here, that's actually my zip file for my AppSync. So that has my GraphQL schema and my VTLs in it. And then this has my my template. So this is my CloudFormation template stack, and then my manifest for CDK and everything. But that's my cloud assembly that gets pushed up into S3. And is also used for doing the diff to create the change set when we do the deploy through CloudFormation. So I'm not going to go into the React app. React is fairly straightforward. I've pulled the source from one of our workshops, so you can actually go and grab the same source and have a look at how it all works. But what I'm doing instead is I've created my own scripts folder. So this little guy here, and there's a few different ways of doing this, right? I'm going to step into why I chose this way of doing it. This little guy here allows me to receive strings or like parameters that I can build into my source, so that when I do a compile, so you'll notice here this export.json, I've run this locally, and you can see that it's actually got my API key and everything. If you're familiar with Amplify, when you do your deploy, and then it says, do you want to synthesize your code or whatever? Not synthesize, sorry, export your code. Actually, no, that's the code for autocode for your GraphQL schema. When you do your deploy with Amplify, it auto-generates an exports.js file, which ultimately is the same thing. It's just creating a JSON object that then gets imported into your application, and then you actually use your configure and you use your exports.js. So the only difference here is I've created it as an actual JSON file. And so when I build, it'll read in the JSON object, and it's doing exactly the same thing. So import reads that JSON object, and then I'm just handing it to the Amplify configure. So now anything in that JSON config that makes sense in terms of the structure that Amplify is looking for, it will actually use. So it will understand my AppSync endpoint, my API key for authentication, all that stuff. So there's nothing that I have to do.
This can be like a slight point of contention. I've had I've had people ask about this like often, and I feel like I never really have like the answer that everybody wants, right? And the thing that I'll bring up here is, and we've all done it, right? We've all done this. Is that this puts not that we're storing credentials. Those are fine because they're all temporary credentials and they're temporary keys. So it's all safe to be able to store that in there. The thing that this does is it produces a manifest that is environment specific. And what that means is, and this might not be like float everybody's boat. So I'm not sure how we'd go ahead and implement this thing. But the caveat to doing any type of builds like this, and especially with Amplify, it does the exact same thing, is that you can't take that exact manifest and move it through environments. You have to recompile because you're compiling into your environment everything that's coming out of like the exports JSON because that exists within the bundle. And so I've seen this before where you're saying like,
yes and
I'm
no,
actually
right?
building my application 3 times for each different environment. Now we presume because we've got pristine pipelines that like it's going to build it exactly the same, but it's still one thing to consider when you've got, I don't know, maybe like a governance requirement around it, or whether you feel that like that's the right thing to do. And I don't really know what the answer is, but I'm pretty sure this is the way I've always solved this in the past, is to basically like publish with my environment either some API that is domain aware, so some convention that's a domain aware of where I pick up the domains, or at runtime I have a file that exists within the folder that does an async call, pulls that in, and then kicks off the app. Anyway, that was just one minor point of convention.
No, I think that's great. A great consideration, right? So you see, as you were saying that, I've actually broken out in the code the actual configuration. All it's looking for is a JSON object, right? So we can actually break that out in code here. If we wanted to feed in all of those parameters as environmental parameters, that's one way we could do it, right? So what I've just done here is one way that I could say, let's build it once and look for environmental parameters. Another way,
except
to
you
your point,
you can't do that though.
Why not?
That won't work because you're like that's a React app that's being built.
Yes, correct.
At build time,
It will still have to
environment
build,
variable,
yes,
but not at runtime. Yeah.
So another way of doing that, and that was the bit that I was just about to get to. So yes, that's similar to what I'm doing here by just calling in an object that exists in the source, right? I could, and this was a discussion point. It wasn't my decision. I could export this into the actual build, right? So then I have my
and then at runtime pull it in.
So then I would have my config here, and then I would have instead of doing an import, I would have to do a read from that file. So it's using the file server, it's using the location, it's reading it in, it's getting the parameters, and then I can still feed it in here at runtime, right? That's another way of doing it.
Yeah.
It's a great call out. The people that I was working with said that no, they want it at build time, not at runtime. So that was the only decision maker. Like I wasn't the decision maker here, but you're 100% right. There's multiple places that we can do it at. So
So that was my point.
Keeping it at source.
Yeah, your pipeline will still build it exactly the same for each different environment. So it depends on how you feel about it, and so some people like I would tend to do this because it's a little bit easier. Once you move it into the next branch, the next branch builds and does it exactly the same because I have consistency with my pipeline and everything's controlled. It's going to build exactly the same, but it's still a slightly different manifest that you're producing.
All my script is here is just a node module, right? So I'm executing a node module at the command line using node. So all it's doing is it's accepting a series of arguments, so parameters, and it's structuring them how I want them structured, and then it's just writing it to that file. So all I would need to do is change source to build, and then drop it into the build folder, and then I don't need to rebuild this source every time. You're 100% right. What I would need to do is in my source, I need to have a utility to read from that file.
Exactly. Yeah. So your bind MJS is, instead of writing a shell script to like produce this out and inject it in at like build time, you've done that nice and codified. Yep.
So yes, absolutely. Here's the important thing, right? So this is what I wanted to jump into. First of all, let me have a look at my app host stack, because I've left some stuff in here that's commented out to talk about SSL certs, Route 53 manipulation. All I'm doing in this app host is I'm creating an S3 bucket and a CloudFront distribution, and obviously an origin access identity. This is a very important thing here. I see many times people actually set this block public access to allow. So so that they're actually allowing public access to the S3 bucket. Just because you're hosting in an S3 bucket for a web app doesn't mean you should be opening your bucket up to the world, because you may still want to store files in that bucket from the server side that you don't want to expose to the world, right? The only way you want to expose your bucket to the world is through an origin access identity token through your CloudFront distribution. So only CloudFront is able to access that bucket, and then your domain is what's hitting that bucket. At this stage, all I'm using is the CloudFront distribution URL, and I'll show you that in a moment. But that also allows me to do HTTPS. If I'm doing an open bucket, it's HTTP, not HTTPS. So that's where we can then tie in our SSL certificate from our domain name to our CloudFront distribution. So all of this, all the app host is, it's an S3 bucket with my CloudFront distribution. But what I said earlier in the episode was that it's very easy to deploy into an S3 bucket. So this construct here, the S3 deploy construct, using a bucket deployment, all it does is it takes a source. So what is what I want to, where is what I want to deploy? So it can take from asset, it can take from an S3 source, the same way that you would deploy a Lambda, and then it takes the destination. So my site bucket that I want to deploy it into, and the distribution. So that's the CloudFront distribution that I'm using for that bucket, so that it's able to access and drop it into the S3 bucket, right? That's great if you've got a static application. So to Paul's point, if we're building the source once, then all we need to do at the synthesize step is have it build. Yeah. Then the front end is built. We can then take this build folder asset and deploy it to the S3 bucket. The problem here is if we're actually changing our source during the pipeline, then we actually need to do a rebuild or of the application, but also a resynthesize. So the way that we get around that is we don't add our deploy step to our hosting step. So in a simplified way of doing things, your hosting and deployment all happen at once. We remove the deployment into the host and we add it as a separate step into. So let's look at this guy here. I've just got a simple app deploy stack. So I'll show you what I mean by it's a simple stack. The app deploy stack is separate to the rest of the pipeline stack. So the pipeline stack will go off and build the backend and give me all of my outputs that I need. The actual deploy stack is a separate stack under the same app. So there's two parallel stacks. The deploy stack takes the CloudFront distribution name, what is that one? Sorry, the name, the ID, and the S3 bucket that we're deploying to as parameters. So now these are input parameters. And then it essentially goes and says, like I said before, we were finding a DynamoDB in the solution. Instead of creating the DynamoDB, we find a DynamoDB. We can do the same thing for our other resources. So my CloudFront distribution, I'm finding it in my account by the domain name and the ID. And then the S3 bucket, it already exists because we've already deployed our app host. So I'm going to go and find it by the bucket name. And then all I need to do is link them to that the S3 deploy. So it's the exact same thing, but it's just in a different stack so that we can then do some stuff between the app host and the app deploy. So let's go and have a quick look at, before I jump into the pipeline, I will show you the backend stack. All we're doing, if you're familiar with the workshop that actually builds this, is we are building a GraphQL API. And to that GraphQL API, in this case, I'm creating the table, but as I said, in the solution, we're just finding the solution based on the ARN that gets fed in. We're then adding that table as a data source, and then we're adding some resolvers. So we've got a create resolver for create data point and a query resolver for query the data point by the specific resolver that we've created. And those resolvers are in this folder here. So my mutation and my query. And that's it. All I want to do from that is actually output the API ID, the URL, and the key. And I will use those in my pipeline. And let's have a quick look at the pipeline itself. So this structure is the same as if you've gone through the CDK workshop, then you'll understand, the first thing that we do is we create our repository that we can commit our code to. So instead of running CDK deploy, all we're doing is git commit and git push. And then everything triggers based in our pipeline based off the git commit. So that's our input, the actual code commit on the branch that we commit to. The pre-install command, obviously, it's going to go and install the CDK CLI. Then we're actually doing our synthesize. But this time, because I've got my 2 stacks, I only want to synthesize the pipeline stack. So anything that is related to the pipeline, which will actually be my backend stage. So deploying all the backend and collecting up all of the resources or all of the outputs that I need for inputs to then go into my front end build, so that we can then bind the URL and the key and everything to our front end build it, and then deploy it. And the way that we do that is the same as everything down to here is the same as what you'll be used to in setting up your pipeline, right? So you've gone and created the base pipeline, which does the synthesis. At this stage, the pipeline, let me jump over to pipelines. At this stage, source, that's our commit. It will receive and download into the build server the code. It will do a build, which is our synth step. This is the very special CDK pipeline self-mutate step. So it will now run through and look at, is there any change to the pipeline itself? If there is, it will actually go and deploy the changes to the pipeline. And then it will go back to the build and synth step and step through again. If there's no changes, it will step on to the next step. Now you'll see here, the output of that is this assets here. So we have one synth step, and that will actually go and build out my front-end application as an asset. So whatever's in the build folder, it'll actually take that and build it out. Now, a problem with that is if I've got nothing in it, because I haven't actually done the front-end build, is it's going to be an empty folder. Or if I've got a static README in there or something like that, it's going to deploy. That asset is just going to have that empty README. And so if we were to go and do that deploy like we had in our app host file that I've commented out, it would deploy an empty folder or that the README file, and that's it. So what we do is we create so obviously we want to deploy the backend. I've separated them out, right? So the backend is just our lambdas, our resolvers for AppSync and all that stuff. I've separated the app host stack just so that I've a separation of concern between, what they're doing. So all this is doing is deploying creating the S3 bucket and the CloudFront distribution. We had a look at the app host stack before. Then all I'm doing is I'm adding another code build step, but you'll see I'm adding it as a post step to the app host deploy stage. So the app host deploy goes and deploys the hosting, but you'll see here that I'm actually taking I'm taking the API ID, the URL, and the key as environmental variables from CloudFront outputs. So whatever the outputs that I've generated from my other stages, I can then now feed in as inputs, environmental variables, into my next stage. I'm also taking the CloudFront URL, the ID, and the S3 name for my actual deploy function, so that it's not going to recreate the app host stuff. It's just taking the stuff that app host deployed and using that function to deploy into the bucket. That's less important than what I want to show you next. As a side, if I wanted to feed in my own environmental variables, it's as simple as environment as an object. And then that guy there is now, if I copy some of these down here, that would be environmental variables, but they won't resolve CloudFormation outputs. These would need to be static variables that I'm feeding in, or using some other SDK to go and get some data from somewhere else to then feed into parameters here. So that's the difference between environment from CFN outputs. These will resolve CFN outputs from previous stages. This won't. They're just static inputs. So what I'm doing here is two things. First of all, I'm actually doing my front end build. So you can see that I'm running npm install to get any packages for the front end application. I'm running my bind script. So the way that I run that bind script there, for those who aren't familiar with how to run node modules, is in my not in my source, in my scripts folder here. It's a node module. You can tell that by MJS, module.js. In my package.json, all I have to do is create a script start build bind here, and all I'm calling is node and the name of the script. So that there will execute a node command to run that script that we have in that scripts folder, and then I can call that from the command line. So if I was on my local development environment, I'd just go node and then give the path for that script. but because I'm on the build server, I can do the same thing. So I'm running the bind script, and I'm feeding in the API URL parameter. So that's coming from my inputs and the API key inputs. Because I'm on the same build server and it's in the same step, then the next thing I want to do is I need to run a resynth to then take the build folder from doing that run build that gets output into the build folder in the root of the project here as a new asset so that I can deploy it. I actually need to do a resynth. Now, instead of doing a resynth, which would then go through the whole process of, or I would have to go and set up all of the deploy and everything I don't want to, I can actually call my CDK deploy from my build server. Now, one important thing to remember here is your build server doesn't actually have the rights or to assume the role to go and do the exact same thing as what your deploy is doing in the previous steps up here, right? So this build server has limited rights or limited permissions, which is a good thing. So what we need to do is, if we're going to run the deploy stage, not just the synth stage, the synthesize stays on the build server. Deploy is now talking into your account. We need to elevate this project, essentially elevate the build server, build step, to then allow us to do the deploy. And also another important one, make sure that we turn off require approval, because if you're familiar with doing CDK deploy from your local environment and it comes in and says, are you sure you want to make these changes? You're on a build server now, so you're not going to be able to say, yes, I want you to deploy. So just suppress any requests for approval.
So
and then you can
just
see
deploy the same role as the deploy role effectively to give it the right permissions to be able to.
I'll show you. I'll show you that in a sec. There's a little magic that the CDK team wrote that I've stolen from them. The last thing that I want to show you here, for those who aren't familiar with how to feed in parameters in CDK, if you want to feed in multiple parameters, you need to use the -- parameters. What do you call this tag? And then the parameter comes after it. So CDN domain name is what I've called it. That comes from, if we go into our CDK deploy stack, all of these guys here. So you see how I'm using a CFN parameter. CFN parameter dot whatever the name that I give it here is what this CDK stack is expecting as an input parameter. So when I do my parameters, CDN domain name, and give it the actual parameter input that I've taken from my CloudFormation outputs from previous steps, that will now bind that to the value of this CDN domain CloudFormation parameter. So now I can actually use CloudFormation parameters inside my stack by feeding them in as parameters. And it's a little annoying, but you actually have to type the -- parameters for every parameter that you want to feed in. So that's how we do the command line to do a deploy. And then the rest works as if you are working from your development environment, right? So to Paul's question, remember, everything in CDK is open source, right? So you can actually go and find all of this code in the underlying CDK construct for the CDK pipelines. Here is the code that you need to use to elevate the actual so I'm elevating a project, right? So my project here is the deploy step. And then inside a code build step, you know how we're adding a project name. Each code build step is what we call a project. So I'm elevating this project, which is this code build step, permission to assume a role, which will allow me to then deploy and adding to the right policy to then go and deploy my resources into the account. So it's as simple as that. So I'm allowing the list bucket, so I can go and find the bucket that I'm deploying to. I'm allowing the CloudFormation describe stacks to go and check the stacks that exist, and I'm allowing the assume role to then go and do that deployment. So have the elevated rights to do the deployment. Without this, you will get an error saying in the command line console saying, I'm trying to do a deploy, but I don't have the rights to do it. That's it. Now, the last thing is the one important thing you need to do. There's a couple of different ways of writing projects and writing your structure for creating CDK. I'm trying to do it in the most compact way, right? I've seen other examples of people who actually build out the project in more of a declarative form. That can be helpful, but in terms of trying to get the most out of writing the least amount of code for the most amount of impact, I'm doing it as constructs. So when I do it as my constructs, the first thing that I do is I need to actually build my pipeline. So that's going to build out the entire pipeline object. So build everything together, which will then allow me to actually elevate the writes. Without doing my build pipeline, it won't recognize the actual project to then go and build out the elevated writes too. That's it. So that's the complexity of adding an additional, when I say complexity, it's not all that complex, adding a post step to our app host. So it's just a single stage. Now, this is to your point again, Paul. You were talking about different stages in terms of dev, test, UAT. If we were to stage this across multiple environments, I might say this is the app host staging stage, and then I might have an app host dev stage and production stage. I would actually have to go and do this, to your point, each time that I'm deploying to a new stage, which I personally agree with you. It would be easier for this to write into our build folder. Now, the problem with that is the asset, even in the build folder, is already created before we get to this step here. So technically, that bind won't be writing into the build folder here. It might be writing directly into the S3 bucket. So now we're deploying a config file into the S3 bucket along with all of the asset deployment that we've had from synthesizing the application here.
Yep. The way, like I said, the way I've solved some of that in the past. The way I've solved some of that in the past is based on the environment that you're running your application from. Like, let's just say it's like local dev, staging, UAT, and then production. Let's just say, for argument's sake, a little bit of logic in the code that directly imports, the first thing it does is do like a call, and it basically does an await call. So an async await call to an endpoint. It works out which endpoint to call based on the domain that you're running it from. Calls like a database, an API, whatever it is, and it's stored in some mechanism that returns back all those keys, and then it goes back on, or a file like from S3 or something. Storing some of that configuration in a database is one way to like not have assets deployed that are hard coded with values, so you can change it on the fly or whatever if you need to.
That's what you're talking now is probably the more common practice. So I've worked across a lot of SaaS solutions where they do something similar, right? They have their control plane, and from their control plane, they might call a CDK app to go and deploy tenant-specific resources. All of the configuration is actually stored in, say, parameter store. So that instead of having to build into the application itself, the application is just reading from parameter store, and then you feed in a tenant key, which comes through the API, and then it pulls that tenant key and says, well, these are all the parameters that I need for that parameter store, which could be the ARN to an S3 bucket or an ARN to a DynamoDB or something like that. So I would actually say what you're describing is the more common practice for much larger distributed systems and also, I guess, multi-tenanted SaaS solutions. And preferentially, I would probably prefer building the config out to, even if it were a file, out to the folder and reading from the file. However, I wanted to show this one because I have come across, it's the important part here isn't that I'm writing config. The important part here is if you are doing any sort of manipulation of your application inside the pipeline, the initial synthesize step creates your application asset once. So there will need to be another synth step. Whether you run it as a synth step or whether you run it as a deploy step, you will need to resynth or redeploy or rebuild, redeploy, so that you can build a new asset with any of the changes that you've added through your pipeline.
The benefit of this is that your application never has to wait to get the configuration to move forward. So it's faster, like it's faster at runtime. Like, so your application loads faster because you don't have that 30, 40, 50, whatever, 100 millisecond wait time to retrieve your configurations before your app starts to bootstrap itself.
This in a way is replicating what Amplify does in the development environment. But instead of having that output generated in your development environment and then doing a build or then doing a commit up to your repository, it's doing it in the pipeline. So it's kind of like a clone on Amplify workflow in the pipeline. For this becomes a lot more appropriate when you're doing your multi-account based structure, or so you're deploying out to multiple accounts. You might have your dev stage in one account, your staging stage in another account, and your production stage in another account. Unfortunately, at this stage, Amplify stages are all in the one account. So you can have multi-stage, but it's stuck within the account. So this takes the same workflow and now allows you to make it more complex across region and account.
Yep.
Yeah, it's kind of cool, right? Like there's definitely pros to using it, and there's definitely cons. Depends on what you're trying to achieve. Like I've kind of stuck to approach that's similar to Paul, but like discovery endpoint with like parameter store, right? In the past, to pull these parameters, and the good thing about doing it dynamically is you know that you've got the current settings like for that account, and so you don't get muddled. Like whereas I know with Amplify in the past, like sometimes like you might be in the wrong account. You just you've got the details for the wrong account and you haven't realized, and then you're doing things. So there's the con of that in this particular approach, but at the same time, it speeds up development quite significantly if you don't really ever need to change too often, right? Yeah.
It also helps. It does get around some race condition issues. So I might deploy or write to a bucket, but then I might go and do a deploy step to a bucket, which wipes everything out in that bucket and redeploys. So there are race conditions that you need to be aware of when doing things like this through the CLI and through CDK deploy and different mechanisms for working with the same bucket. This just gets around all that. It's not as to both of your point. Yeah, it's one way of many ways that could handle the same thing. I'm just thinking, like, I actually, funnily enough, this afternoon am going to an engagement where I will be writing a CDK application to handle receiving a request into an API to then go and trigger a pipeline to go and build out tenant assets to then deploy the resource ARNs and everything into the parameter store. If that's something that the audience wants to see in action, I'd be happy to, again, clone that and show a very simple version of that on the show. If you want to see how we do initializing a pipeline from a Lambda as opposed to from a code commit, running a CDK app deploy with parameters that we're feeding in so that it's tenant specific, and then writing all of that to the parameter store. That probably is a little bit more complex than this, but now that you've seen this, it would make a lot more sense. It's kind of just a step on top of, and simplifies it in terms of there's no multi-deploy or multi-synth.
Nice. I think Shebang on the chat would love to see it. Paul's got to jump off for another engagement, so he's just quickly exited. But I know that we're right up on time as well. It's been pretty awesome. Yep. I do really like Amplify's system of having the like local configurations, right? So I do really like that particular flow that you've got there. But I think it comes down to there's so many ways to solve a problem. It depends on what you're actually trying to solve. So that dictates the approach. Yeah.
when working with enterprises, the enterprise IT department will always have a curly way of saying, yes, you can do it this way. No, you can't do it that way. So we have to have multiple ways of doing things because we have to work with different organizations' constraints.
And somebody wants to see the Lambda that you created as well. So I might put your screen back up. We can do that for a second if you don't have to run.
There's no Lambda in this one because it's all it's the resolver VTLs.
Yeah,
so it's VTLs. The Lambda that I'm talking about is the engagement that I'm going to today is the API Lambda proxy that takes all of the input from the API that then feeds as parameters through the the actual SDK that talks to pipelines and feeds them as parameters into an app, a CDK app, which then goes and deploy resources in the account that the pipeline is in, specific to so one of the parameters is the tenant name. So it creates an S3 bucket with the tenant name. It creates a DynamoDB with the tenant name. It goes and it actually even creates a Cognito user pool so that each tenant has their own Cognito user pool. And then it writes all of the outputs of that to parameter store. So that when that's part of the control plane, when a tenant logs in with their key, which also, it also creates a usage policy, which generates an API key, which is the tenant ID. So when the tenant receives that key and they start making queries to the API, now there's a Lambda that goes and talks to parameter store and says, oh, that's the S3 bucket, that's the DynamoDB, that's the, actually for the first step, that's the Cognito user pool, and it does an authentication on the actual specific tenant user pool.
Yep. No, nice. That's it's awesome. You did remind me as well. Like, you know, one of the things that that would be impacted by this is if I'm actually doing local mocking with AppSync.
Yep.
So this is something that I do when I want to test things locally. So, you know, local stack, Moto Free, if you're using any of those, they're pretty awesome products. But, you know, like with Amplify and other suites, when you're using like AppSync, you actually have local mocking capabilities as well, which makes it kind of fun. And I have seen that basically, like when you do local mocking with AppSync, it will wipe out your current settings for Amplify. And then when you shut down the app, it's theoretically supposed to reverse that as well. So that
theoretically doesn't
that
always.
might cause I said theoretically because it didn't last time. Yep.
I just want to call out Daily Push. I'm not going to answer your questions now. These are very important questions, like shifting the tokens and everything. What I will do is I'll say, okay, we'll do an episode on that stack deployment. So a multi-tenanted stack deployment, and I can show you, and you can see how we're actually handling tokens.
Yep. No, that would be awesome. I know you've got to go as well, Aaron. Trying to think if there was anything else that I was going to raise, but I think we're good. So we have someone special booked in for next week, I think. Do we?
We do. We're actually going to be looking at some Web3. So
Web3. That's right.
We're starting to put together content around Web3. I know it's a contentious. It can be contentious term in some circles, but essentially what we're looking at is blockchain, smart contracts, tokens, NFTs, and starting to look at a lot of the underlying technology. So we'll look at Solidity, the language, Ethereum, the chain network, and working with a wallet, so a digital wallet. That's next week with Gonzalo Ron. So if you're interested,
and then we've got some stuff on Amplify later. It would be really interesting seeing how this evolves. The other project you're talking about, looking into tokens could be good. I feel like local mocking might be something that I do towards the end of the year as well.
That's a good idea.
We
talk about it a lot, but we haven't demoed it really.
No, and it makes development, like speed a lot faster. There was one other thing that I was going to say. I'm just trying to think. I'd remembered it again before we cut off. Anyways, it'll come to me, and I'll talk to you later, Aaron. For now, let's wrap the session up, and we'll catch everyone for some Web3 same time next week. Excellent. Thanks everyone.
For your commentary. It's been awesome.
Thanks everyone. Bye.
Bye.